A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I welcome you all in our today's online session, Applied Physics, lecture number 10. Hope you all are fine and having good health. We start today's session with the verse of Holy Quran. In previous session, we was discussing about forces and forces on negative charges. So these two figures tells us that if a positive unit positive test charge is moving in between north and south pole within the magnetic forces lines passing through from north to south pole, and the force which is experienced by the unit positive test charge, that particular we already discussed in our previous session. So that particular force we found by right hand rule. This concept was the first one that in previous session we were discussed, and after that we coming towards the left hand rule for negative charge q. In negative charge, if it's flow from a negative unit negative test charge, if it's move in between north south pole, then the lines of forces experience the particular force we can found by left हैंड रूल. तो इसे हम सीधे हाथ का कानून और उल्टे हाथ का कानून कहते हैं, जिसकी मदद से हम ये मालूम कर पाते हैं कि वो चार्ज जो कि मैग्नेटिक लाइंस ऑफ फोर्सेस बिटवीन दी पोल्स मूव कर रहा हो, आइदर दे आर दी पॉजिटिव और आइदर दे आर दी नेगेटिव, तो वो फोर्स जो वो एक्सपीरियंस करता है वो F इज इक्वल टू क्यू वी बी साइन थीटा हमने लास्ट टाइम डिस्कस की थी, और उसको लेफ्ट हैंड रूल और राइट हैंड रूल की मदद से मालूम कर सकते हैं. इन प्रीवियस सेशन वी डिस्कस दिस दीस काइंड ऑफ कॉन्सेप्ट्स. वी फर्दर मूविंग टू द नेक्स्ट स्लाइड of today's session. Indicating the direction of B fields. One way of indicating the direction of fields perpendicular to the plane is to use across X and dot. A field directed into paper is denoted by across. The field direct into the paper is denoted by X, like tail, feather of an arrow, like this one or this one. So that means the lines of magnetic field is going inside the paper. It's a 2D aspect, that is the magnetic field are going inward direction, not the outward. Now the next concept of the slide, a field directed out of the paper is denoted by a dot symbol, like front tip end of an arrow, like the opposite direction arrow, and this arrow is reflect in this way, that dot notation. And dot means lines of fields are out of paper, which means it is moving from inside of paper towards to our face. And this notation denotes or tells us the lines of forces are going from our face direction to that particular paper. So this is the inward and this is the outward direction field of force of magnetic lines of forces, which is flow from outside the paper and inside the paper, if we talking about the 2D model of that particular magnetic lines of forces and magnetic lines of field. So practice with the direction. So what is the direction of force F on the charge in each of the examples described below? So it would be the upward direction and the left direction, upward again right direction. So negative q and these kind of concepts you already understand, because these are the concepts are we already discussed in our primary and secondary classes. So these are the basic magnetic lines of floating concepts in and outside, from and inside the paper. Now this is the main topic which we're going to discuss today, that crossed E and B field. So E is the electric field intensity and B is the magnetic field intensity. So combination of these two fields we're going to discuss here. The motion of charged particles such as electrons can be controlled by combined electric and magnetic field. We know that if a particular charge is exerted on a region of space, then the electric lines of forces flow from a unit positive test charge in particular region or aspect. And if that particular charge is moving some distance, then the magnetic field would be created. Again, I am repeating the concept. If a stationary charge is placed into a region, then electric field would be produced. And if the charge is moved, then magnetic field would be produced. So this is the origination concept of electric field and magnetic field, electric force or magnetic force, electric field intensity and magnetic field intensity, same vice versa concepts going towards another statements as well. Note the electric field intensity of force on electron is upward and opposite E field. But the magnetic flux density or magnetic field intensity force on electron is down left hand rule. The third concept is zero deflection when F of B and F of E are equal. The particular force of magnetic field intensity and electric field intensity are equal, then deflection of charge would be zero deflection. So we can see that the upward and other two concepts are so this is the thermionic emission or the charge sheet experiment by which the electron gun floored the electrons in between the positive and negative plates. Then the electric charge of electron negatively electron charge passing in between these two plates, then the charge of negative of electron would be strike on that particular screen and moving with the certain velocity. That particular charge experience the magnetic lines of forces which is produced in between these two positive negative poles. So the particular intensity is in downward direction and the direction of velocity is in this one of charge, but the force by the electrical intensity moving towards the upward direction. Now the second concept here is which we going to find by the left hand rule, that the force direction of magnetic flux density is moving downward direction, velocity have this one, and the magnetic flux density is this one the direction. The velocity sector coming towards the next aspect, that this device cross field to select only those velocities for which f of B and f of E are equal, which means verify the direction for plus q of charge. Source of charge. Source of charge means it's a particular kind of electron gun or charge gun which fire the electron from starting to end of this plane. So electron gun fire electrons, or we can create the charge of electron in continuous motion by thermionic emission. So these two are the concepts by which we can get the electron, by electron gun or by thermionic emission. Thermionic emission is a heating effect by which the electron can be ejected by some of material, and electron gun concept is the particular cyclotron or electrotron concepts by which we can get the high velocity electrons by the experiment, which we also discussed in our previous classes and engineering first semester of physics. Further, uh, when we get that particular electron, which is flowed from this direction, the orifice plate in between lies that if electron direction or proton direction is not in equal spacing, then some of electron can be bound from these boundaries, and the direct line of sight electron or proton can be flowed in this direction with some certain velocity, that is the v. So when the magnetic force and electric field intensity of force are equal, that certain position of equation which we found, QEV equal to Q into E. So we know that the force experienced by a charge having formula F of V equal to QVV, and the force which charge experience in electric field intensity, that particular formula in previous lecture we already discussed this thing, E equal to Q into E. In both sides, Q would be cancelled, and we got the formula V equal to E divided by B. So this ratio of electric field intensity and magnetic flux density, we got velocity. So that's the reason it's called the velocity sector, because by which we can find the velocity of charge by this aspect. By adjusting the E or the field B, a person can select only those ions with the desired velocity. Either they are the positive or either they are the negative. So circular motion in field B. So this concept is the centrifugal force, centripetal force, and the curl operation can also provide this concept. The magnetic force F on a moving charge is always perpendicular to its velocity V. Thus, a charge moving in field B will experience a centripetal force. And centripetal force, we very well know the formula Fc equal to mv square upon r. If a particular mass of object is moving in a circular motion with certain velocity, it also create the radius of r, then the force experienced by the particular body of mass, we can set that it is Fc, centripetal force. Now we know that the formula of Fb equal to QVB. To combine these two forms of forces with each other, comparison. After the comparison, we got mv square upon r equal to qvb. The radius of that path is r equal to mv divided by q into b. That the particular formula of radius of centripetal force by which we can find r equal to mv divided by q into b. So that particular formula we can found by this way. Centripetal force and the magnetic force experienced by a charge, we can say that in this figure. Further, the mass spectrometer, ions passes through a velocity selector at known velocity emerge into a magnetic field as shown. The radius is r equal to that particular formula of centripetal force, and comparison with the magnetic force, at the end was we drive r equal to mv divided by q into b. The mass is found by measure the radius m equal to, which means that after the rearranging, we can found the mass of that object q into b into r divided by particular velocity by which the charge is moving. So it's a photographic film on which the charge is entering, and after the slide, and it would be distributed in this way, and different kind of velocity of moving vectors, we can find different masses aspects in different charges, and by which they are moving with velocity of centripetal force. The concept is already applicable in the mass spectrometer concept. For the numerical, we skip it. Now it's the end of this lecture. So in summary, we have to conclude here what kind of concepts we discuss here. The direction of force on a charge moving in an electric field can determine by the right hand rule for positive charges. and by the left hand rule for negative charges as well. So the right hand rule, left hand rule, both we discuss in our starting session. Afterwards, the concluding theory of F is equal to QEB sine theta, the force experience, the charge experience the particular force that we called F is equal to QEB sine theta. The velocity by which the charge is moving in the concept of thermionic emission or electron gun concept. This is also one of the cathode ray experiment as well. And the spectrometer concept we also discussed here. And this is all about the conclusion of our today's session. So up till now, if you have any kind of question or query regarding today's lecture or session, please feel free to ask. I will answer the kind of concept and resolve your queries if you have in your mind. Hopefully all the concepts have been clear in your mind and have no kind of question. So we going to end today's session, lecture number 8 of flight physics.
आप सबको खास नसीहत समझे, वसीयत समझे।